Hey everyone, thanks for joining. John here, senior software engineer with 10 years of experience. Today we're practicing the LeetCode Kata. This is interview preparation for whiteboard interviews, coding challenges, and so on. Blog article number 3 at latterly.io. Latterly is an educational platform. It's open source, helps you land your first or next programming role. So you can sign up for free, you can join the Discord, check out the events calendar, which includes streaming events like the current one, and then also Tuesday, Thursday, Saturday, I do evening streams in addition to Monday through Friday, sort of middle of the day streams, 3 p.m. Eastern. And the next evening stream, we will be working on open source contribution rather than LeetCode. And so we'll be working on this pull request number 250 to improve Latterly, which closes a bunch of issues. So stick around if you're interested to that. That will be tomorrow. And follow the page because I might stream later today just for kicks, an unplanned sort of irregular ad hoc stream. Okay, so that's the background. And then let's go to the LeetCode Kata. We're going to do whatever we can get done in an hour. So officially, I think we'll complete 1 through 6. And then I think we'll get to number 7. And I don't know if we'll complete 7. There's a possibility we even go on to 8. I don't know. We'll see. But that is the actual target is I think we'll complete 6 and then probably not complete 7. Okay, so we'll start with TwoSum. It's the first sort of a warm-up problem on the Latterly LeetCode Kata. In this case, the array is already sorted. And the problem reads, given a one-indexed array of integers called numbers, this array is already sorted in non-decreasing order. Why do they say non-decreasing instead of increasing? Because you might have duplicates. You might have 1, 1, 1, 2, 2, 2. It's non-decreasing, right? So you're given this numbers array, and then you're given a target. And you want to find 2 numbers in the array that add up to the target. Let these numbers be the index sub 1 of numbers and the index sub 2 of numbers. And this is the one indexed. So 1 is less than or equal to 1 is 2 and so forth. They need to be different. Notice 1 and 2 are distinct. Thanks for the heart. Can you explain OOP? Not right now. Not right now. Yeah, no, just Google it. That's going to be a much better use of your time. Okay, so in this case, we want to return the indices of 2 numbers, index 1 and index 2. So we want to return the indices. We want to return them in the array format, and that array will always have length 2. What language? We'll be doing this one in Python. I can do JavaScript if you're interested, but we're planning on Python. Thanks for being here. Thank you for the likes. Use Code Forces. What's up, you good? Welcome, welcome. And you can see that we will always have exactly one solution. So we don't need to worry about the case with no solutions, and we don't need to worry about duplicates. Okay, so complexity. Given the array is already sorted, I can use 2 pointers, which will need to scan every element in the worst case. So time complexity is O of n, and space complexity is constant. So we'll place the left pointer at the far left and the right pointer at the far right. So this is like a collapsing window in possible contrast to a fast and slow pointer or a sliding window, which also use pointers. So there are a few different ways to use pointers, but this is like pointers across the whole array, and they're going to be collapsing towards each other. There's no need for them to cross, so we can use this while condition. We're looking at a sum, right? So if the left ever crosses right, then we're just going to have the same sum. So picture the numbers like my array is 2, 1.
So I have left over here and right over here. They add to 3. Now the pointers cross. Well, it's a duplicate. 1 plus 2. So I'm going to get duplicates, and they're going to get the same sum. So I just shouldn't even check those. So what's the current sum in this case? It's going to be left plus right of numbers. Left plus right of numbers. And then let's compare that current sum to the target. So there's 3 cases. Whenever we compare them, there's 3 possible cases. The sum could be above, below, or equal to. So in the equal case, we found our target, and we should go ahead and return the 1 index. So since my left on line 7 is initialized to 0, the 1 index left needs a plus 1. Okay, now the above case is a pseudocode. What's the literal to say that my current sum is above the target? There's the literal expression, and the reverse here. My current sum is less than the target. So these are the possible cases, but we need to do some activity here. Can you share a link to download the IDE? This doesn't need to be downloaded. It's just leetcode.com. It's built into the browser. So I need to do some activity here. The current sum is too large, so I want to reduce that current sum. So picture my left and right pointers, and we have this index, this array where the indices are sorted and the values are sorted. So my right one points to the greater, my left one points to the lesser. Is it reversed on the screen? Is it reversed for you guys? This is left, right? Left. I think we're good. So if I want the sum of these to decrease, remember my left starts at 0, so I can't very well move left to the left. I need to move right to the left. And then in this case, I want to increase the sum. So I do the reverse. I increase left instead of decreasing right. Are you seeing the pattern here and the logic here rather than just memorizing the solution? So the pattern here is 2 pointers. So we have these kata. It is a memorization-based approach. But why would we do like similar problems? What does it even mean for problems to be similar? It means they're using the same pattern. So that's the idea of the meta flow in the kata. It's not pure memorization. It is memorization-based, but it actually unlocks a meta flow where you're deeply learning patterns and you're creating a sense of comfort for yourself, because this one is like this one. So you get into this kata-based flow, which also happens if you do like martial arts and you do, so kata is like derived from martial arts. If you do the movements, you'll have like a muscle memory and you'll feel really comfortable. And we're trying to transpose that idea into the cognitive realm with the laterally lead code kata. What site is this? Laterally.io. You can see the link in bio and sign up for free. All right, so now let's go on to the next problem in the kata. Now that we've done 2 sum, we'll go on to 3 sum. And the problem reads, given an integer array called nums, let's return all of the triplets ijk of nums such that ij and k are distinct. So this triplet is a value triplet. And the sum of the values is 0. Notice that the solution set must not contain duplicate triplets. So it's doubly deduplicated. It's deduplicated on the index and on the values. On the indices and on the values. And here in the case of example 1, you can have duplicate values within a solution. So you have -1, -1. But -1, -1, 2 as a triplet cannot be duplicated. Isn't that interesting? So you have a 2-way deduplication, but within the triplet, you can have duplicate values there. Something to be mindful of. Another thing that's interesting about that is there are multiple answers. And then the example 2 brings a third complication where we need to consider the sad case where there are possibly no valid answers. Kwasi says, I'm enjoying it, but the GUI is small to view. Hey, check out the link in my bio. You can visit YouTube or Twitch and see the full screen. Yeah, it is hard to see on TikTok, isn't it? So come on over to YouTube. By the way, the stream will be recorded on YouTube. So if you missed part of it, you can always go back. And there is a playlist. There's a playlist of solutions on the YouTube channel. So if we go over here to playlists, you can see here's the LeetCode Kata in JavaScript. Here's the LeetCode Kata solutions in Java, here in Python. And there's other development streams that have nothing to do with LeetCode, as well as if you're interested in learning to code, I run small groups, and there are some clips from small groups here. You can also sign up to join the small group by signing up for Premium. So if you sign up for Premium, then you can message me or I'll message you or I'll see your email because I'm an admin on the website. Some way you can get connected for the small group. If you want, you can also do this. You can go to settings and scroll down and say, hey, I'm interested in an expert-led small group. You can flag that. We'll follow on YouTube. Great, thanks for being here. All right, back to the code. So what's the approach here? The approach is we just did 2-sum, now we're doing 3-sum. Let's do 2-sum, and then that target can add with some third number to 0. You see how they're related? Approach, sort, and use optimal 2-sum solution, which is 2 pointers of n. KB, welcome, welcome. Then add a third pointer as a wrapper. This does not alter the overall time complexity. Yes, it does. That's a total lie. This multiplies the time complexity by n. So target time complexity is O(n) squared. But it does not alter the space complexity, which is still constant because it's just pointers. Tic-tac-toe, thanks for follow. Are you using React and Material UI? Not for LeetCode. I mean, I have done that. I don't know if I have any active open source projects that do that. Probably if you look around my repositories, you'll find one, but I don't think I'm actively working on any of them. ShadCN is the UI. ShadCN and Tailwind are the tools that I like to use these days. So you can check out ShadCN and Tailwind. And so this is what Latterly is using. Material is cool. Like, I don't hate it, but I like these other tools more these days. One of the reasons that I like Tailwind more is that it is officially recommended by the Next.js and Blitz.js teams. So if you use Create Next App, whenever you install, it will ask you if you want to use Tailwind. KB says, I'm trying to figure out a problem at work. Come over to the Discord. We can chat about it after the stream. There is a programming help channel. You're always welcome to take advantage of that. And then if it's something where you need like more help and maybe you can't share it on an open channel, like, you know, if it's sensitive and you don't want to put it on a Discord, you can book an expert session and then I can consult with you one-on-one. These expert sessions, by the way, are not just for one-on-one consultation with individuals. As a corporation, you can use these to enlist developer services at a pretty good rate, $80 an hour. Is a lot cheaper than a lot of contract approaches, isn't it? Okay. So we want this outer pointer. What do we call it? We'll call it far left. So that'll be 0. We also want to make sure that we sort nums. Costs in log n, time complexity. It's not binding though. So it does not impact our overall worst case asymptotic time complexity because n log n is less than n squared asymptotically. What data structure you use when using the 2-pointer algorithm? Hey, JWavy, pointers are a data structure. Pointers are a data structure. So when you use the 2-pointer algorithm, you've already said the data structure that you should be using. That is 2 pointers. Okay, so we sort, we have this outer wrapper, and now I just want to do while that wrapper scans across all of the values. While far left is less than length of nums minus 1. Get complement. We're going to call toSum. We're going to fast forward dupes. And then we're going to eventually return results. So let's declare results as a set. And we want to use a set for auto deduplication of tuple triplets. So remember, we can't have duplicates. In Python and in some other languages, we're fortunate that the set takes care of that deduplication for us with any internal hashable structure. So the internal structure needs to be hashable. That's why we want to use tuple triplets instead of list triplets, because in Python, the list is not natively hashable. Python's list implementation is a dynamic array. Same with JavaScript. Multi-paradigm, they try to make it easy for you. If you're in another language where you need to specify the allocation of the array, then it might be hashable. Check with your, I don't know, spec. But safe bet that if you have access to a tuple, it's going to work. Siga, thank you for the follow. Alfredo, welcome. Good to see you, Alfredo. Man, every time I see you, I want some pasta. Okay. So let's get the complement. The complement is going to be, that is the thing which adds to 0. So that's going to be the opposite of the value. That's my nickname. Gotcha, gotcha. So it's going to be the opposite of the far left of nums. Why is that? Because now if I use my toSum and I find that as a target, the toSum solution and this far left index will add to 0, which is my overall goal. Make sense? Okay, so we do that. Now let's call self.toSum. We're going to want to pass it results, or is it result or results? Let me add an S on there. I guess it doesn't matter, but whatever. It needs to be consistent whether or not it has an S. So I want to pass it. I want to pass my toSum method the results set so that if I find something, I can add it in. The other thing I need toSum to be aware of is it needs to be aware of the complement, doesn't it? It needs to be aware of nums, and it needs to be aware of far left, because I don't want to look over all of nums for every invocation of the toSum. I only want to look in that window, which is to the right of the far left. So I need to pass it the far left so it knows where to like create that new window. Are you trying to solve it in nlog n? No, because that would be impossible. Correct me if I'm wrong. I think academics have been over this problem. I don't think you can solve 3sum in nlog n. So we're going for O(n) squared. Target time complexity is O(n) squared. Unless we get into quantum computing, which I'm not trying to pull out quantum computing in a whiteboard interview. Maybe that would be a good bluff. Maybe if you're totally lost, you just you pretend that you know quantum computing, and you're like, well, if the interviewer can't say I'm wrong, you like write out some assembly. The syntax is totally wrong, but the interviewer doesn't know assembly either. I did it in nlog n squared. That sounds wrong, Alfredo. That sounds wrong. Okay, let's carry on. So here is toSum. KB says, what are you solving? This is going to be 3sum. You can see the name up there. Sorting, then 2 loops. Sorting, then 2 loops. Yeah, I don't think that's nlog n squared. I think sorting, then 2 loops is what I'm doing. And that is asymptotically just n squared. The nlog n drops off. I think the nlog n drops off. Java, please. No, I do not do Java for interviews. It's harder. It's harder for me. I mean, if you're super pro in Java,
Awesome. I'm very happy for you. I've done it. I've gotten offers in Java, and it's just like painful, and my conversion rates are low. They're non-zero, but they're low. Okay. So what else here? Is this everything it needs? Maybe this is everything it needs. And then let's fast forward dupes. So we'll say while, and here we're going to increment far left. So while it's a dupe, how do we know if it's a dupe? Complement isn't changed. That's how we know it's going to be a dupe. But before we check if the complement isn't changed, we need to make sure that we are in bounds. Okay, so there's going to be two sub-expressions in this check. Shane, thank you for the follow. Imagine doing this in C++. Yeah, I could never. I mean, there are some people who can, and that's really cool. Good job. I say I could never, but like if I spent a ton of time on it, I could get there. I just really don't want to do that. You see what I mean? That would take so much practice. All right. So how do we know if we're in bounds? We know that we're in bounds by just recycling this same expression. Far left is not greater. Oh, wait. Far left just needs to be less than nums, not less than nums minus 1. Far left is less than nums. Lengthwise, then we're in bounds. Alfredo says, I used Python for Amazon, got to the last interview, but failed. Hey, you can always try again, right? If you want to. You can always try again. What is their cooldown right now? Is 6 or 12 months, something like that? Complement isn't changed. How do we check that? Well, we just say, we just use this expression. But we need to change it a little. We need to say that the complement is on the right hand. We need to say that the complement is on the right hand. So that's effectively caching. And then we are incrementing far left, and we're saying, hey, like, is it still that? If it is still that, we need to skip forward more. Ellie, what are you doing? Lay in bed, honey. My upstairs neighbor, who is also my daughter, is moving furniture, and she's supposed to be napping. Okay. This looks good. We just need to make twosome now, right? Let's go make twosome. So what are my arguments? Here are my arguments. Okay. So I need to create this new window that's a sub window that's to the right of far left. So my initializer here will be far left plus 1. And then right, it's still the end of nums. And then we use our twosome that we already did, while left is less than right. Let's see, I guess right should be length of nums minus 1. Oh gosh, I would really hate to have to end the stream to go have a talk with my daughter. Ellie! Hey Sam, what are you doing? Ellie, lay in your bed. Okay. So we have left, we have right. So let's get our sum. So the current sum is left plus right. And then we know that the current sum can be above target, below target, or at. In this case, we want to append results and fast forward dupes. That's the structure of this twosome here. All right, let's
change it from pseudocode to real code. So left and right need to do a lookup on nums. Sum is greater than complement. Otherwise it's less, otherwise it is the match. And here left is going to, hold on. So here we are greater, so we need to move right, not left, sorry. Here we want to increase left because our sum is too small. So the Kerr tuple is always going to be sorted far left, left, right. But we want a tuple of the values, not the indices. So let's do the lookup. Here I notice that I'm repeating myself. So nums left and nums right. So I'll extract that, call this Kerr left, Kerr right. Okay. And now I want to fast forward the dupes, which is pretty much the same pattern as used up here, but our caching number could be right or left, current left or current right. You can perturb either. I'll arbitrarily pick left just because our whole mental model here is that we're moving left to right. So let's go ahead and perturb left and move left along. So here I'll say while inbounds and Kerr left is unchanged, then we will increment left. So how do we know that we're inbounds? We can just use this expression, which is already our boundary condition, and nums left is equal to Kerr left, and that's our caching condition. Oh no, we're wrong. What did I didn't append the answer, did I? Okay, so we have results dot append. Is it append or add? I don't know. We'll find out if it errors. Cool. Yeah, some big tech companies, I mean, if you're doing an online assessment, you need to be right. Good thing you can usually run these tests before you submit, just like LeetCode. But some big tech companies, especially for the final loop, you actually don't run the code at all. You're just talking to the person, and you don't even need to worry about if it's append or add. They're like, yeah, whatever, either one works. We know the abstract thing that you're trying to do, and we actually don't care so much about the syntax. It would be nice if we can get to a place where auto-graded online assessments like CodeSignal and so forth had a similar ability to appreciate that aspect. All right, unfortunately, I got to end the stream for now. My upstairs neighbor, although she said okay, she has resumed moving furniture. Follow the page. I'm definitely going to be doing the problems that we talked about. I'll just have to break it up into a few smaller streams, apparently. So